Here we are in section 3-2 with the numbers 5 through 8. Number 5, fill out a table for each of the following. So we're going to stick numbers in and see what we get out for partners. So let's try this. 2x plus y equals 9. Here we have x is 5. We'll mark it with this color. 2 times 5, so 5 is going in for x, so we get 10 plus y equals 9. Subtract 10 from both sides, and we get a y equals a -1. Excellent. Then the next one we'll do with this color. Stick -4 in where x is, and we get 2 times -4 is a -8 plus y equals 9. Add 8 to both sides, and we get y equals a 17. Good. Next one, we'll use a color orange right here. We get 3 going in for y, so we get 2x plus 3 equals 9. Subtract 3 and we get 2x equals 6. Divide by 2, we get x equals 3. Oh, so 3, 3 works. That's interesting. Okay, the next one, we'll use this color right here, pink. Stick 0 in for y. Oh, I like sticking in 0. We have 2x plus 0, which is just 2x. 2x equals 9. So we divide by 2 and we get x equals 9 halves. If we were to graph that on the calculator, we'd probably want to stick it in, graph it on the graph, we'd probably want to stick it into the calculator and get 4.5. And then finally, what else? 7 goes in for y. So we'll use a green for that one. So we stick in 7 right here for y, and we get 2x plus 7 equals 9. Subtract 7, we get 2x equals 2. And then divide by 2, we get x equals 1. All right, that's a completed table. And all of these points, 5, -1, -4, 17, 3, 3, 9 halves, 0, 1, and 7, those are the coordinates for 5 of the points on that line. Good. All right, number 6. Let's see what we get here. We're going to stick in 2 for x. So let's do it with blue here. And we're going to do 2 times 2 is 4 minus 3y equals 5. Subtract 4 and we get minus 3y equals 2. And then divide by a -3. So we get y equals 2 over a -3. That's a -2/3. Okay, now let's do the next one here. We'll use this purplish color. Stick in 0 for x. Oh, that's nice. If you stick in 0, you get 2 times 0 is 0 minus 3y equals 5. Divide by a -3, divide by a -3, and we get a -5/3. Okay, the next one. Let's pick red here. -1 goes in for x. So we have 2 times a -1, that's -2 minus 3y equals 5, and solve for y. Add 2 over here, and we get -3y equals 7. Man, we're just getting hit with a lot of fractions, aren't we? 7 divided by a -3, that's a -7/3. All fractions on that one. Let's see if we get any better once we start sticking in numbers for y. Okay, so let's use this burgundy color here. Stick 0 in for y, and we get 2x minus 0 equals 5. Divide by 2, divide by 2, and we get x equals 5 halves. In the calculator, it'd be about 2.5. So 5 halves there. And the last one, stick a 4 in for y. So if we take 4, and again, we'll draw that little picture just one time. We're actually doing this each time. So we get 2x minus 3 times 4 is 12 equals 5. Add 12 over there, and we get 2x equals 17. Divide by 2, and we get x equals 17 halves. Ooh, every single one of those answers ended up being fractions. Wow. All right, number 7. Here it says graph the following lines, and we only need to label 3 points. We can use a little bit bigger marker here. Label 3 points. It doesn't tell us which ones to stick in, and we could be sticking in very different ones. So we get to pick the numbers to stick in. Good, because there are some that are easier than others. So let's come over here and let's try 3 points. I'm going to do 0 for x. I like sticking that one in, and we get y equals, it's writing that one down, that'll be y equals -3/7 times 0 is 0 plus 4. We get y equals 4. So 0, 4 will be about right there. Then another, what's a nice one to stick in? We got a fraction here. If we want to get rid of the fractions, let's stick in like 7. If we stick it in, we get y equals -3/7 times 7 plus 4. That's -3. Go ahead and either multiply that in a calculator or see that the 7's can cancel. Plus 4 gives us a 1. So 7, 1. It's going to be about right there. And we can see where the line is, but they want one more point. So let's stick something in that hopefully will turn out nice. Let me see, 3/7. Oh, if we did, we could do a -7 for x. That would also cancel fractions, or a 14 would be fine. Y equals -3/7 times 14 plus 4. That gives us -6, I think, plus 4 is a -2. And so 14 out here and down at about a -2, something like that. And so the line looks like that. Not too bad, a little squiggly, but not bad at all. Okay, let's try the next one over here. Number 8, 6x minus 5y equals 12. So 6x, let me see. Let's do a little xy plot over here. Let's stick in 0 for x. Let's see what that looks like. 0 for x, and we get 6 times 0 is 0, minus 5y equals 12. Minus 5y equals 12. We have to divide by a -5. We get y equals 12 divided by a -5, or a -12/5, which in a calculator would be about -2.4. All right, let's try 0 for y. It's not by itself, so it should help if we stick in 6x minus 5 times 0 gives us 6x equals 12. Divide by 6 and we get x equals a 2. Right, that one worked out very nice. Okay, and then we know where the thing is. Let's go ahead and graph those 2 points. We can see exactly where it is. 2 zeros here, and then 0, -12/5, so a little bit beyond 2 is there. So that's where the line is going to go. Let's get this third point. I don't know, let's stick in 3. Stick in 3 for x. So let's see what we get. 6 times 3 minus 5y equals 12. So 18. Subtract 18 from both sides. -5y equals a -6. Divide by -5, and we get y equals a positive 6/5, which is like 1.2. So if we go out to 3 and up about 1.2, yeah, look, that's on the line. That's good. And if you would like to use graph paper or put tick marks there to help you gauge where those numbers are, really these are just sketches, not needing to be totally precise, but you can kind of see where they are roughly, and these graphs would be sufficient.